Hello everyone, today we will talk about generics in Java. Generics can seem super confusing and complicated if you see them for the first time, with all these T, K, V, angle brackets, and question marks. But I will try to make sure that by the end of this video, you won't be scared of them anymore. You have probably already used them without realizing what they were. So, let's break down generics, why they are needed, why they are useful, and how to use them in your program. Let's go! I mentioned that you have probably already used generics, so let's take a look at them, and you'll see that there's nothing complicated about it. A familiar notation, I'm sure. So, this is one interpretation of generics.
Oh my god!
In this case, the list interface can use both strings and numbers. This is precisely thanks to generics, rather than just generalizations. Generics are special features of the Java language for implementing generic programming, a specific approach for describing data and algorithms that allows for working with various data types without changing their descriptions. There is a good article on the Oracle website, and the link will be in the description. To better understand what generics do and why they are needed, it is useful to know what problems developers faced in Java before their introduction. Yes, they appeared, if I'm not mistaken, in the S5 version. Let's say I want to create a class that will store a string that I provide, and then print it to the console whenever I want. Let's name the class printer. It will have one field for storing a string. For example, let's use world. Great. Let's create a constructor using the keyword this. I would like to remind you that it is necessary for each Zapper class to have its own value for word. Literally, this parameter belongs specifically to this Zapper class. Now, let's create a method that will output our string. Next, in our main method, we need to create an instance of the Zapper class. Let's say we have a string printer and immediately using the constructor we add a string to it. Everything will work perfectly. We can call our print method on our string builder that we created earlier. Of course, everything is fine, but we print not only strings, but also numbers. These can be int, double, or long. Essentially, they can also be whole objects. Of course, there is always the option to create several classes, but they will have minimal differences and a lot of duplicated code. Let's just take a look at this. I created them in advance. As you can see, the differences are minimal. This is where generics come to the rescue. Generics allow us to create a single class that is flexible and can work with multiple data types. Let's return to our printer class and make it a generic. If you want to use generics in a class, as in this example, you need to define what is called a type parameter immediately after the class name but before the curly braces. You place this parameter in angle brackets. Let's call it T. In Java, this parameter is usually referred to as T, K, V, but technically you can name it anything you like. Well, not exactly anything goes, except for the question mark, but more on that later. I will be using T, which is possibly short for type. This T represents any type that will be stored and output by this printer. Thus, instead of having a field of type string, it will now be T, another fix in the constructor. And everything is ready, but how do we use this class? Let's return to our main class, and we see a warning. The compiler wants to know what data type we want to use. In this example, we want to use a string. We specify this in angle brackets after the printer. And we also specify angle brackets on the right. In older versions of Java, we needed to specify the type within those brackets, but this has been simplified. This string parameter that we specified in angle brackets will be used instead of the given T. We can also specify multiple parameters T, K, which is a valid notation. Arrays can also be specified, and that is also a valid notation. Let's make our printer class accept two parameters. To do this, we just need to make a few adjustments to the code. Now our printer class can work with any two types. It will process as many as needed. Let's check. Now it accepts, for example, string and integer. Great. Let's output to the console. Right. Works with any types. It can be anything, integer, double, long, anything you can come up with. But the best part is that you can now remove unnecessary classes. Remember earlier we created printer for double and printer for integer. Now we simply don't need them. We have just one class, printer, that can handle any data types. Numbers with a decimal point and integers, strings, objects. Of course, there are some specifics when working with generics. Generics do not work with primitive data types, such as int, with a lowercase I. It is necessary to use the corresponding wrapper classes, and everything will work. It is also worth noting that during runtime, t is replaced with a specific type of object, and in the code itself, you cannot do anything with it. For example, you won't be able to use records of that type. Great. Now let's return to our very first example with ArrayList and create an ArrayList. But this will not be an array list of strings. Instead, I have pre-created a class called team. It has just two fields, string name and core integer, a regular constructor, and an overridden toString method. You know that when we normally print objects to the console, it won't show what's inside, so we must remember to override it. Our array list will consist of teams. Let's add a couple of teams. Suppose we also have a class called people, a regular class. But if we try to add it, since we previously specified that we are only working with team, we would be trying to insert people. And here you may rightly wonder, why not just create an array of objects? After all, object is a common parent for all objects, without any generics, and you can add anything to it. In fact, you can do it this way and everything will work. Great. It now properly accepts both commands and people, but now our list is not type safe. This could lead to a heap of problems later in the code. Let me show you what I mean. Now our list contains both commands and people, but in reality it contains not commands and people, but everything in the form of objects. Let's add some method to our team. But this method only exists for team. Let's go back and take the first element. Ideally, we should be able to call our getName and score on it. But no, it won't be there because our array doesn't contain team and people objects. It consists of object. An object doesn't have a getName and score method. As a result, by using list, object, you lose the advantages of generics since you don't specify a concrete type for the element. This can lead to an increase in runtime errors and more complex code. We can also restrict the types of generics. For example, we have a previously created class called team, and let's say there is also a team of adults and teenagers. They both extend from team, and we want our printer class to work only with subclasses of the team class. We will make a few changes. Let's move on to the main class. We will now create our printer. Similarly, we can create one for a teenager. Let's check, they both work. This is thanks to the fact that in the printer class we specified extends team. And in each of the classes, it is specified that they extend from team. Or here is another good example. You know that the common parent for all numbers is number, so if we specify t extends number, of course with a capital letter, now you can use the printer for any type of numeric values. Everything works perfectly as well. In the constraints, you can also specify interfaces. However, if you are using inheritance from both classes and interfaces, you should list the class first, followed by the interface using an ampersand. Otherwise, it simply won't work. Let's create, for example, an empty interface. Now in our printer, we extend from number and through the ampersand interface. Everything will work for us. Most likely, you have come across this kind of notation in the documentation or in the code. This is a wildcard. What is its uniqueness and how does it differ from a regular t? The notation. T_extends class is used when you define a generic type in a class or method. She says that t is a certain type that must be either a class or a subclass of it. The wildcard extends class is used when you want to work with objects of any type that inherit from a class. However, you do not care what specific type it will be. You do not define a specific type. You say it can be any type that inherits from a class. Theory is great, but to be honest, it's not very clear. Let's take a look at the code. We'll create a class called AnyNumbers. I've created it in advance, so let's have a look at it for now. The AnyNumbers class, which extends from number. It has a first and a second. two fields. It has a constructor and a method. Let's call it print as always. It takes one object and outputs it to the screen. Great. Let's try to use it in our main method. We'll create two objects. We will have any number based on integer and any number double. Remember, we created a method that prints the contents to the console. Let's try to use it. And we pass our second one, but we encounter an error because it expects an integer and receives a double. Not only could I say that we have any number, but it works with all subclasses of number. However, this is where the trick lies. T is defined once as integer, and when we call it on our first object of type integer, passing a double here causes a type mismatch. This is where Wildcard helps us. Just one change and everything will work. But why? It's worth changing this T to a question. Everything works. If we recall the theory, T is defined once and remembers that value, perhaps. By calling on the first objects that used integer, we immediately indicate that we will only be using integer going forward. The wildcard is more flexible, but only within the defined boundaries of the class and can easily adapt on the fly. So, the main advantage of using generics is that they allow you to write flexible code that can be used for various data types while maintaining type safety. There are many possibilities associated with generics, such as creating methods, interfaces, classes, type constraints, and so on. I hope this video has provided you with a foundation for understanding the basic aspects of generics and helped you grasp what they are, why they are useful, and how to start using them. If you have any questions, feel free to leave them in the comments. Otherwise, thank you for watching.